So I'm gonna back up a step so that we kind of cement in some of what we learned about the confidence interval. So there's a document on Blackboard. Here's the lab session 7. This document called exercise 1, lab exercise 1. I'm gonna open that up. It's a Word document. And there's 3 problems on there. And I'm gonna start with the second problem because it's a little bit more familiar to us than the other 2 are, I think. Okay, and I'm gonna read it, and it's gonna be a basic look at the confidence interval again. Okay, so we go to randomly select, unfortunately it's St. Patrick's Day example. It could have been a Halloween example like the homework, but what are you going to do? Randomly select 40 New York City pubs. I didn't even think about this, and find that the inventory that on the average they inventory 42 types of beer. You calculate the standard deviations for those pubs from your study data and find that it's 6.3 beers. So you went to 40 pubs, the sample size is 40, and found that on the average they carried in one form or another, bottles on tap or whatever, 42 different kinds of beer. And that standard deviation for the number of types of beer that each bar carries is 6.3. So what do we know here? We know X bar, right? We know the mean, which is 42. We know the sample size, which is 40. Do we know the population standard deviation for all bars in New York City? No, we don't. So the only thing we can do here is estimate the population standard deviation, sigma, from the standard deviation of our sample. Turns out it's 6.3. Okay, we could have a lively debate right now over what we're going to define as a large sample. Like from one perspective, you could say that, gee, if I want to assume that I really know what sigma is for the population, I want a really big sample, like 200 or 300. If on the other hand, I want to say, well, I really don't have a good handle on it, we might say less than 30. So for our purposes today, I'm going to say anything bigger than 30. A lot of textbooks tend to do this. Anything big enough than 30 is big enough for me to say that I have a pretty good rough idea what sigma is, and I'll use that as sigma. I'm just doing this on purpose so I can contrast that to a really small sample. So let's take a look at what we know here. We know, and let me just open this up, give myself somewhere to write. Okay, I'll ignore that number. Okay, so we know X bar was, what was it, 46, 42? And the sample size is 40. And we're going to say that we know sigma is equal to 6.3. Right? We're going to assume that that's a big enough sample size for us to estimate what sigma is. So if I wanted to calculate a 95% confidence interval for this, I would say to myself, well, I'm going to start, the middle of my confidence interval is going to be my point estimate or my mean. So it's going to be X bar plus or minus, and my margin of error, what I'm going to subtract and add to X bar in order to get my 95% confidence interval is going to be my Z-score, right, for a 95% confidence interval, times my standard error. Okay, my standard error is going to be calculated based on the standard deviation of the population over the square root of the sample size, or 6.3 divided by the square root of 40. Okay, so what am I going to use for Z? If I decided that my sample size was large, right, big sample size, what can I use for Z? Yeah, 1.96, right? Okay, if it's small, then I have to deal with this extra uncertainty, and I can use the t distribution instead. So I'm going to say X bar is 42 plus or minus 1.96 times my standard error, which is 6.3 divided by square root of 40. So let's calculate that. I'm going to clear this out. 6.3. Oh, hang on a second here. Let me do the square root of 40 first. 40 square root going to put that into memory. And I'll clear that. So 40 divided by the square root of, 6.3 divided by, let me try this again. 6.3 divided by the square root of 40. So that's going to be equal to roughly 1, right? I got a little lucky this time. Now, I'm going to take that standard error and multiply it by 1.96, so I'm going to do that right now. Oops. Got to do it again. Let's see. 6.3 divided by memory times 1.96 is equal to 1.94. Okay, so this whole thing, I'm not going to worry. My whole margin of error is, see what it was again, 1.94, right? Yep, 1.94 plus or minus 1.94. So our confidence interval is going to be 40.06, right? And 43.94. Thank you very much. Good. You save a lot of time if you help me out with these things so I don't make a mistake. Okay, so what does that tell us? What does that mean exactly, that confidence interval? What does that tell us about this world where we have Irish pubs that have a lot of different kinds of beer? What does it tell us about that world? It tells us that the true mean is likely between these two numbers, right? What level of certainty do we believe we have here in terms? Yeah, now we're 95% sure the true mean for all the pubs in New York City, all the Irish pubs in New York City, is between these two numbers. We don't know it for sure, but now at least we have a range and a level of confidence. If I were going to calculate this where I wanted to be 99% sure, would the range be wider or narrower? Wider, because I want higher certainty. And what would make it wider? Is there what changes in here that makes it wider? Right, z-score, right, exactly. The z-score changes, right? So instead of a z-score 1.96 for a 95% confidence interval, for 99% confidence interval, I would use a z-score of 2.58. Why 2.58? 2.58 because if we look at the normal distribution, right, when we want to capture 99% of the possible outcomes, we're looking for 0.5% at one end of the outside of that range and 0.5% out above that range. So that would represent a value that's 2.58 standard deviations from the middle, right? So that's why we use that to represent 2.58. And we would go to our table to look that up. Well, how about if I'm satisfied with a 90% certainty? Would it be narrower or wider than this range we have now? Narrower, because we can afford to have a narrower range because we're willing to accept a larger chance of being outside of that. So what area for a 90% confidence interval, what percentage of the possible outcomes would be below and above the middle 90%? What would this be? Right, for a 90% confidence interval. Right, 90%. What's going to be on both ends? 5 and 5, exactly. 5% here and 5% here because we're accounting for the 5%, the 10% of the probabilities that we're going to get a sample outside of that range, right? If we really have this, if this is really true, that this is the true mean and that's the true standard deviation. So that's where and what's the z-score for that? That's going to be a smaller z-score because we want a smaller margin of error. That's going to be 1.64. Okay, so if we remember those three numbers, right, we're halfway home.